Hello everyone. Can someone confirm am I audible or not?
Yes, sir, you are audible.
Thank you. So I'll start by giving you an introduction of how this tutorial sessions is going to be like. Mm, so I hope you are going through the main lectures that are there in the website, and these will have some assignment problems from previous years and some problems which I gave my own. And most of these tutorial sessions will be interactive. So by interactive I mean I don't just take classes where I solve some problems and you guys like take notes or something like that, but I will try to make it more interactive by asking you questions, and feel free to unmute yourselves and answer. And so you will have to like answer any way you can like you can unmute yourself and answer, or you can answer on this chat, anywhere you like, but you have to interact. Okay, so okay, so shall we start or shall we wait? Okay, before starting, can you kind of introduce yourself? Like, I want to know what is your background, what are you studying right now, something like that. One by one, maybe. So that will help me like understand how much I have to explain and how less I have to explain. Someone start. I'll take names. And Anjali Suman, are you here?
Hello, good afternoon, sir.
Hi, good afternoon. So,
Yes, sir. I'm Anjali Suman. I'm currently not studying. I'm looking forward to enroll in masters. I have done my graduation with physics subject.
oh, you are going for your master's degree. You are a physics background. Um,
Yes, I have a physics background. I've done my graduation in physics. I'm looking forward into masters, doing masters in physics.
okay. Thank you. Next,
Yes.
Aisha Jahash. Pardon my pronunciation.
Good afternoon, sir. Myself Aisha Jahash. Currently, I'm pursuing MSc Physics, sir. So for that, I'm doing pursuing this course, sir.
Okay, next. Okay, so I have to take the name. Navia Thomas.
Good afternoon, sir. My name is Navya Susan Thomas. and I'm doing BSc Physics.
BSc Physics. Nice. Okay.
Yes.
Thank you. Next is Pavala Murthy.
Good afternoon, sir. Myself, Pawalamurthy. I am studying physics. Thank you, sir.
Physics. Okay. Next will be, uh, sh- pardon my pronunciation, Shrine Anto Josko. Yeah,
Good afternoon, sir. My name is Shaina Tejosko. I'm studying BSc Physics.
BSc Physics. V Haripriya.
Yes, sir.
Good afternoon, sir. This is Haripriya
Hmm. Yes.
from Chennai. I'm currently pursuing MSc Physics.
Okay. Okay.
Thank
So,
you.
okay, thank you. So I think I covered all of them. So anyone is anyone here who is not have a physics background? Okay, I think everyone is from physics. That makes my work easier because this course is purely physics. Sometimes in NPTEL courses, there are people I encounter who are not from physics background, so I have to explain bit more than usual for the physics background students. But since you all are probably done your BScs and doing your BScs, it is going to be easy. At least this first session is going to be really easy. It's about vectors and dot products, cross products, etc. etc. So I'll introduce myself. I realized I didn't do it. So I am Sahil. Currently, I am doing my PhD in IIT Hyderabad, and my area of research is computational physics, and I apply physical intuitions to understand biological systems. Feel free to contact me if you have any doubts about these courses, other outside the regular 2 hours time. And one more thing I want to tell you that is there a discussion group in the NPTEL in the NPTEL lecture series? Like there is a discussion group. There usually is, right? Okay. Okay. So I'll come back
Yes,
to
sir.
that. Yeah, I'll come back to that about that discussion group. So shall we start?
Yes, sir.
Okay, so today will be how many of you have not gone through the lectures of week 1? You can tell me, like, don't get stressed, or we'll have a discussion. No worries about it. If you have not gone through it, you can tell me.
I have not completed the full lecture, sir.
Okay. Okay, fine. That's completely fine. So first week lecture is about vectors, and I am pretty sure everyone here knows about vectors, right? Anyone here does not know what vector is? What is the definition of a vector? Okay, some two new people have joined. Just a minute. Avinaya and Aisha, I guess. So I'll ask another one more time that is anyone here who is not from a physics background, like BSc physics and MSc physics, who is not from a physics background? Okay, fine. So who will tell me the definition of a vector? Very easy. Class 12 question.
Sir, vector is a quantity that has,
Hmm. Which has?
sir,
Yes, go on.
vector is a quantity that has magnitude and as well as direction, and it obeys vector law of addition. Some of the examples of vector are displacement, velocity, angular velocity, and force.
Okay, nice. Correct. And anyone disagrees with him? So let's go into this. So there are some. So we'll be solving some problems and questions. First one is tells which of the following is true about mass and weight. Who will tell the answer? So what about answer 1? Is it correct or not? Someone? Mass is a vector quantity, weight is a scalar quantity.
So mass is a scalar quantity and weight is a vector quantity.
So this is, according to you, this is right, correct answer, right? So everyone
Both are
agrees?
scalar. This is
Okay. Both are
both
scalar
are
quantity. So this got 1 vote, this got 1 vote. Anyone? Anyone else?
Both are scalar quantities.
So it got 2 votes. Then
Both are scalar quantities, sir.
who is saying Haripriya? Okay. Next. Anyone else?
So mass is a scalar quantity and weight is a vector quantity.
So
Okay.
mass is a scalar quantity,
Hmm.
weight is a vector quantity.
Okay. Now it is tied again. Anyone wants to break the tie? Anyone? Not all of you are voting. So if you are not sure, that's also okay. Okay, so whoever is saying the option D has to justify that mass is a scalar quantity. Okay, everyone agrees that mass is a scalar quantity, correct?
Yes, sir.
Yes. Uh, so the disagreement comes in the fact that weight is a vector quantity, right? So so whoever saying weight is a vector quantity, why do you say weight is a vector quantity?
Because its unit is Newton.
Okay, because its unit is Newton is not, this is a correct statement, but that is not the reason. Okay, what is, let's say we have a mass m, okay, so what's its weight placed on a table like this. So this is the mass, okay, and what will be the weight? Anyone knows? So weight is the force felt by a mass due to gravity, right? Okay, so everyone got silent. Am I disconnected or what is going
Yes,
on?
sir.
Okay. Okay, Anjali Suman is saying that this thing I wrote is correct. Anyone disagrees? So definition of weight is, let's say you have a mass. Uh, okay, hold on. Something is off. Pardon me, there is some technical issues from my side. it is back. You can see the screen, right?
Yes, sir. The screen is visible.
Okay, thank you. So weight is defined as the force a mass m is uh, is felt due to the gravity. So in this example, this box of mass m feels a force due to gravity in this direction towards the g direction. Okay, so that's why weight, since also although we don't always tell the in which direction the force is or the weight is applying, but it's always assumed that it was in the same direction as gravity. That's why weight is a vector quantity. And whoever said, I forgot the name, who said this Newton unit, that's why it has a unit of Newton, because it's a force. This is the same reason you will hear that our weight will change if we go to moon. Why? Have you heard this statement? That
Yes, sir. Due to change in gravity, gravitational force.
exactly. So weight is defined as mass times acceleration due to gravity. So mass times acceleration due to gravity. So this acceleration is a vector quantity. Everyone agrees with this, right? Acceleration is a vector quantity. So this is why weight is actually a vector quantity, not a scalar quantity. So this is the right answer. Okay. So all three of these, three of you who said weight is a scalar quantity, do you agree or do you still disagree? Okay, you are neutral now.
We understood, sir. Weight is a vector quantity.
Okay, okay, okay. I hope you guys are on board with me. Please stop me and ask me questions if you don't agree with me in some cases. Please don't hesitate. You don't have to. So I don't think of it like a teacher or any professor is teaching you. I'm just a student like you guys only. I just finished my MSc a few years ago, and you are also in the BSc MSc circuit. So just try to have a normal conversation where we discuss about stuff and try to learn whatever is there on our plate. Okay. So next question is, which of the following is not a scalar quantity? Displacement of a mosquito in space. Okay, let's discuss this first option, displacement of a mosquito in space. So a mosquito starts here, it goes there, randomly, anywhere. Let's ends here. What is the displacement of this mosquito? Let's say this is our mosquito. What is the displacement?
A straight line from the above point from the to the downward point.
Like this. This is the displacement. Everyone agrees with I think Anjali. Everyone agrees with Anjali?
Yes, sir.
Yes. Okay. Okay, if you disagree, please tell me. Otherwise, I will assume everyone agrees. So this is the displacement. So what is this? Is this a vector or a scalar?
It's a vector quantity, sir.
And why?
Uh, because it has both magnitude and it shows the direction.
Yes. So you have to tell that at which point mosquito started and which point it ended. If you don't include this arrow, by this only this line, it's not possible to know where the mosquito started and where the mosquito ended. So that's why to define displacement, you have to define its direction. So that's why displacement is a vector quantity. So we have to look which is not a scalar quantity, right? That means which is a vector quantity, that's what we are looking for. So first one is vector quantity. Next one, light intensity in drawing room. So what about it? Does it have a direction, light intensity? No, right? It's either bright or less bright. It has a magnitude difference. It does not have a direction, right? So if you guys don't respond anything, I feel like I'm disconnected. My internet is not good. Is it like that? Okay, my internet is
No,
fine.
sir, we are able to hear you
Okay, okay.
clearly.
Okay, say something, like at least do this raise hand thing or write in the chat. Okay, so another thing, if you feel like I am going too slow, that also please tell me. So if you don't tell me, I'll go in this pace. If you tell me, then I'll go fast. Maybe these are very basic for most of you, but I'll go in this pace unless you ask me to. Okay, so light intensity is not a vector quantity. Everyone agrees or not?
Yes, sir.
Okay. Okay, so I'll explain what is light intensity. For defining light intensity, you don't have to define that. So light goes from one point to another point, that has a direction, but the intensity, like you have to tell, okay, this part is bright, this part is dark, and in between there are some bright spots, some dark spots, but there is no directional sense involved. That's why it is a scalar quantity. Temperature distribution in your classroom. Now who will tell you? Who will tell me what is this? Someone else try, please. Anyone? Okay. Okay, anyone? Temperature distribution in your classroom, scalar or vector?
Scalar.
Scalar.
Scalar quantity.
Okay. Atmospheric pressure in a given region.
Pressure.
Pressure.
The scalar sign.
Scalar. What is the definition of pressure?
Force by area.
Force per area. So what is force, scalar or vector? Vector. What is
Vector.
area? Scalar or vector?
Vector.
So how do you divide a scalar and a vector? Yes? No, how do you divide two vectors? Do you know? Anyone knows? Maybe a term? What is this? It is a scalar or vector? Is it a scalar or is it a vector?
Pressure vector only.
Is it vector? No.
This is vector only.
No, I think you haven't learned about this. So, in what ways we can explain? We can write a vector like a matrix, right? Like fx, fy. Do you know this notation?
Fx.
It's an array or a matrix like this, right? So there are some quantities, not let's say some quantities, who are written as let's say q. Q is a quantity which is written as matrix. So this is a 1D matrix. What is the dimension of this matrix? 1 cross 2, right? This is also 1 cross 2. This is a 2 cross 2. So there are some quantities that you describe it via 2 cross 2 matrix. So vectors, so scalars you define, let's say a scalar A, no not A, M. Look, Okay, so scalar S is defined as just a scalar quantity, right? You can define it like this. For vector, you can define a vector like this, a 1D array with just two components. If you have a third component, you will have a third dimension, fx, fy, fz. Okay, this you agree, right? Are you getting what I am trying to say? So what I am trying to say is, you can represent scalar is as just a number. You don't have to have any components, right? You understand the concept of components of a vector?
Yes, sir.
Okay, so let's say vector f has two components, fx and fy. So you can write it as an array or a matrix of dimension 1 cross 2. This you have learned, heard ever?
Yes, sir. In graduation, I have learned this.
Yes, in graduation. If you have done your graduation, you will know this. Anyone else is struggling with this concept? Forget about this. Forget about this for now. To represent the vector like this, everyone has seen it or not? Like everyone has, I'm pretty sure everyone has seen this representation, right? If vector, let's say vector A equals A I cap plus B j cap, or A1 I cap, A2 j cap. This you have seen, right? I'm pretty sure everyone has seen.
Yes, sir.
Okay, so instead this same thing I can just drop this I and j and write it as a matrix. Why? Because it's already known that there are I caps and j caps. These are just the component representation or matrix representation of a vector. Okay. Then okay, okay. Till this point, everyone agrees or not? Anyone having difficulty?
No, sir.
Yes or no? What do you say, Shrine? And to let's go.
No, sir.
Okay. I couldn't hear you properly. I think you understood. Okay. So then there comes another kind of quantity which is represented as a 2 by 2 matrix or 3 by 3 matrix or higher dimensional matrices. These quantities are called, anyone knows the name?
Tensor.
Tensor quantity, yes. So what tensor quantity physically means? So scalars have only magnitude, vectors have magnitude and direction, then scalars has to have something more. For example, taking force per unit area. Now force has 3 component, area has also have 3 component. So what does this tells you is pressure will have 9 components. Why 9 components? Oops. Why 9 components? So force, let's say in 2D, okay. So let me give the example in 2D. So this is x cap, this is y cap. So you have this force, and okay, in 2D it is a bit weird to this. So let's say force as fx I cap fy j cap plus fz k cap, and area is similarly ax I cap plus ay j cap plus az k cap, right? We can write it like this. Now this fx force is acting along which direction? X direction, and this
Yeah, in the direction of x-axis.
yes, again
In the direction of x-axis.
exactly, and this ax is also in the direction of x-axis. So this force along x-axis divided by unit area along x-axis gives you the pressure in that axis, right? Along that direction. Similarly, Fy by Ay will give you the pressure in that direction. Similarly, Fz by Az will give you the pressure in that direction. But this division, so force along x-axis, but what is its impact in the area vector along y-axis? This, let's say you have a block like this. This is your x direction. You apply force along this direction, and it became like this. Okay. So this force, and you kept this term fixed. Now the displacement happened in this direction, but the change, the deformation happened in this direction, y direction. So F was in x direction, but in y direction you see a change, right? So whenever this kind of changes happens, we have more than just vector quantities. There comes these kind of quantities which are called tensor quantities. Okay, maybe you will learn it in more details, or you know it already. I have explained. Yes, you, Anjali, you want to say something, or you just agreeing or what?
No, sir. Would you explain once?
Once more.
Yes, sir. Would you explain once more?
Okay, sorry. Okay, so let's say whenever you have a 3D object, okay, let's say you have a 1D object like this pen. You can see this pen. Okay, now you apply force in this direction. In this direction, you have a pressure in this direction. Like you can define a pressure in this direction, right? But if you have a deformable object which is not very symmetric like this, for example, let's say this paper, okay, now applying force in this direction can make any deformation in this direction also, in your direction, because it's not a very symmetric object, right? But you
Yes, sir.
applied force in one direction only. Let's say you have a mud like system, a mud. Now you apply force in one direction, and there is some displacement happening in another direction also. Okay,
Okay, sir.
so how do you define what pressure is applied in the other direction? Same way, that force per unit area, but this unit area is not in the same direction of the applied force. So now you have pressure in the direction of the force that you have applied, and
Yes, sir.
pressure in the direction of the other direction where the force was not applied also. Okay, let's see. Let's say you have this object, you applied force in this direction, it moved in this direction. Okay, so for displacement you have vector quantity because its movement is in one direction. But let's say you have this kind of an object and you deformed it by applying this kind of force. Now the deformation is not unidirectional anymore. Like you can't just say, okay, this deformation is only in x direction or only in y direction or in any other direction. It can be of any direction. Like it can be this direction, this direction, this direction. It can be in any direction, right?
Yes, sir.
That's why these other directions, this not, so the force was applied in one direction, the other directions where the force was not applied, to take care of that we have to have more information, and this more information gives more components to the quantity. So when you go from scalar to vector, for scalar you only had magnitude, but then when you required to define the direction also, you had to have one more component, right? One more quantity, that is direction and
Direction.
magnitude. Yes. For this kind of quantities, you need more than that. So these new kind of quantities are called tensor quantities, where this only magnitude and just the direction is not enough. You have to define the other directions that are getting affected by the vector, by the force.
Okay, sir.
Yeah, so that's why this kind of um, representation is required. This means force in x direction, area in x direction. This is force in y direction, area in x direction. These cross terms are important now. So these are called shear terms, and this is called the pressure term. And this is different discussion. So anyway, so where were we? The atmospheric pressure. So pressure in general is a vector, is a tensor quantity. Okay. So read about it. You have to read it more to fully understand what are the tensor quantity. There are stress strain is a tensor quantity. Uh, mm, Stress tensor is a tensor quantity actually, and the diagonal term of the stress tensors, these terms are actually represented as pressure. Okay, so you can define pressure as a scalar quantity or a tensor quantity, not a vector quantity. Okay, so it is not a scalar quantity, that is wrong. Okay, so it was, this is wrong. So only this is the correct answer. Okay, not a scalar quantity. Okay, yes, fine. Shall I move on? Okay, you understand cross products and dot products.
Yes, sir.
Okay, everyone else, anyone else, let me check. So okay, so from now on, till the rest of this class, we'll deal with different kinds of cross products and dot products and their concepts. Okay, anyone, Haripriya, you understand cross products and dot products? Okay, maybe she is not. Ramesh,
Hello.
yes, you understand this cross and dot products, I guess. MSc Physics, you are.
Yes, yes.
So I
Kind
think
of.
everyone will understand. So what is wrong with this equation? Who can tell me this equation? What is fundamentally wrong with this equation?
So the dot product of two vectors gives a scalar quantity and the cross product of two vectors gives a vector quantity. So
Exactly.
these two equations, this equation is invalid.
Invalid. Yes. So in an equation, always check if the left hand side and right hand side are matching or not. For matching, I say that if the left hand side is a vector, right hand side has also have to be a vector, or if it is a scalar, it has to be a scalar. Now let's say I change this question a little bit. I make it the magnitude. Okay. Now tell me, Ramesh, can you mute yourself for now? Okay. So now what will happen? Now it is a valid equation because this is also a scalar and this is a vector, right? No, sorry, both are scalar now, correct? Agreed?
Yes.
Yes. Now you tell me in what condition this can be true. How do I proceed? You tell me, I'll write. And yes,
A cross B is equal to AB sin theta. And A dot B is equal to AB cos theta.
so you said A, B, so
A dot B is equal to AB sin theta. A dot B is equal to AB cos theta.
okay. Now, so these are
Sin theta is equal
magnitudes.
to cos theta.
Yes. And theta equals
Cos theta. Then
theta equals pi by 4, right?
yes, theta is equal to 4.
When do sin theta is equal to cos theta?
Pi by 4.
Yes, 45 degree and its multiples. Okay. And if any one of it is 0, then it is always correct. Correct? Easy question. Next, we have two vectors f and g, where x, y, z are unit vectors in x, y, z direction respectively, and f, g are in the same direction, and then gy. So they are saying f and g are in same direction. Then what we can write about it? Then they are asking what is this gy? One unknown quantity is there. How do I start? Anyone else want to answer? Manisha, SS, Aisha, Atul. How do I start this
By
question?
equating these two equations, because both these equations are in same direction.
In same direction, they said. They didn't say in same. Uh, they are exactly same. So you are saying f equals g.
Yes, sir.
So that means mod f equals mod g, same magnitude, right? Which is may not be correct because they said in the same direction. Let's say this is a vector and this is a vector. They are in same direction, but they are not they does not have the same magnitude, right?
Yes, sir.
Yes, but there is a trick. So for two vectors, if they are in same direction, then you can write some multiple, scalar multiple of this of one another, right? So if it has a smaller amplitude, it has a bigger amplitude, you just multiply its unknown scalar amplitude to the smaller one and can write it as a bigger one, right? So you can write it like this: Cg. Cg. Now this equation becomes C mod G, which is correct. This C can be anything. If F is a longer displacement and G is a smaller displacement, that then C is a greater than one quantity. And if the opposite, like if let's say F is a small displacement, G is a big displacement, then C will be some fraction. But you can always write this. Am I right?
Yes, sir.
Okay. Now let's see. So let's start from this equation. So f is 2x cap minus 6y cap plus 10z cap equals cx cap plus c times gy y cap plus, is it plus, right, 5z cap. Is it plus? Yes, it is plus. Now we can equate component to component. So this and this gives us c equals 2. Also this and this, sorry I missed a c here, right? So 5c equals 10. This also gives you c equal to 2. Now the finally let's equate this and this. What do you get? Minus 6 equals c gy. So gy is minus 6 by c, and we know c equals to is minus 3. So this is the correct answer. Fine. Everyone got it? This is our
Yes.
final answer. Okay. Nice. Okay. This is an interesting question. It is asking the component of this vector along this vector. What do they mean by this along thing? What do they mean by this along thing? So the component, read it carefully, the component of this vector along this vector.
The projection of this vector along 3x minus 5 vector.
So what do you mean by projection? So
Component.
you know the you say. So I am asking like what is the physical definition of it, physical intuition of it, or let's say. So how do you do it? Tell me. Do you know any formula like component of vector A along vector B?
Yes, it is a magnitude divided by direction. Magnitude. Direction divided by the vector quantity.
Direction divided by the vector quantity. Of what?
I'm confused.
So okay, so I think what you are trying to say is something like this. I think some may remember some formula like this. Anyone?
Yes, sir. Yes, sir.
Do you remember this formula? This is the formula straight up. Like this problem can be solved by this formula. It is in the BSc first year. Anyone else? Is the formula correct? And why the formula? I think Anjali was trying to say this, or am I right?
Yes, sir. I was trying to say this.
Yes, but you forgot. Okay, but I will tell you how not to forget it today. Anyone else wants to say something here? Okay, so let me try to give you some intuition about this projection or component of a vector along another vector. Okay, so let's say I have a vector A which is ax x cap plus ay y cap plus az z cap. Okay, now if I ask you what is the component of vector A along x direction?
Yes.
Ax, right? Ax. So what is the component of vector A along z direction or z direction?
Az.
Az. So this question is exactly same. Instead of asking it in x direction, y direction, z direction, they are asking in some another vector direction. So let's say I try to do the same thing, and so if let's say the question is what is the component of vector A along y direction. So what we will do is we will take a dot product with the vector we are asked, with the unit vector of the direction we are asked. What will happen? Ax x cap dot y cap plus ay y cap dot y cap plus az z cap dot z cap, right? So the question was, what is the component of vector A along y direction? To answer that, we see that if we take dot product of that vector and unit vector along that direction, what will we get? What is this right hand side answer is? What is x cap dot y cap?
0.
0. So this guy is 0, and sorry, I wrote it wrong. This is y, this is z, sorry, z cap dot y cap, right? So what is this?
This is also 0.
This is also 0, and this
1.
1. So you end up getting ay. That is your first answer. Now I ask you, what is the component of this vector along this vector? So whichever direction you want to go, you have you calculate the unit vector along this direction, right? Let's say this is b, 3x cap minus 4y cap. So what is the unit vector along b direction? Vector b by mod b, divided it by its own magnitude, so that this guy's magnitude is 1. So this is the unit vector along that direction. Now component of A along B direction is just A dot B cap. This is the component. And then you got the formula which we started with, right? Agreed, everyone? Atul, Navia, Thomas.
Yes, sir. Okay.
Yeah, you are understanding, right? Just tell me if you have a doubt. Okay. So you got how the formula came. The formula started with. So this is why the component of a vector along another vector means taking dot product of the vector with the direction you are asked. Okay. So now let's do this. So b mod b is 3 square plus 4 square equals 5,
5.
right? And a dot b by mod b is 6x cap plus 2y cap minus 3z cap dot 3 by 5 x cap minus 4 by 5 y cap. Yes, I guess you can do this. 18 by 5 minus 16 by 5, no sorry, 8 by 5, 10 by 5, I think 2 is the answer. Okay. Fine. Shall I proceed to the next question? Okay, who will answer it quickly? What about the first option? This one. Is it correct or not? You already discussed this. Archana Ba, are you here? Anyone else? Aisha? Satya Devi? Okay, anyone else? Anjali?
C is the answer.
C is the answer. Why not C or B? Can you tell again? I couldn't hear you properly. C or B?
Option C.
Option C.
Option C.
Okay, you guys are saying option C. Why? So why not A? Because it is a vector scalar cross. D also same, right? Left hand side is scalar, right hand side is vector. Left hand side is vector, right hand side is scalar cross. C because it's associative property or what? So A dot B dot C equals B dot C dot A. Because no matter which one you do first, it's gonna give the same result, right? Do you have to show
Yes, sir.
it? Calculate? No, right? But why not B? So A, B. Which direction A cross B goes? This rule you remember? Right hand thumb rule. So A cross B goes in
Upward direction.
upward. Let's say this is n cap. Then I can write mod A, mod B, sin theta n cap. Okay? And what about B cross A? Mod B, mod A, sin theta this is, let's say, m cap. Okay, can you tell any relation between n cap and m cap?
Directionally, they are opposite to each other.
Exactly. So can we write m cap equals minus n cap?
Minus n cap.
So this we get sin theta n cap. This is A cross B, right? Then what do we get? Is it so? So this is also correct. B and C both are correct answer. You can get both multiple correct options in your assignments. Do them. Okay, the same theme. These statements are meaningless. So this is meaningless. This is also meaningless. This are fine, right? I'm not gonna spend much time on this. Agreed or disagreed? Okay. A force F is applied to an object which then have a displacement d. F is given, d is given, work done is asked. So what is the definition of work done when you have force and displacement given?
Dot product of force and displacement.
Yes, F dot T. You can do this, right? I'm not gonna explicitly show what is the answer. So anyone have like you know how to do this? How this, what this means? 2, 3, 1. And
2x I cap plus 3y j cap
yes, exactly. So
plus
this is
1z
this is
cap
what I was
plus
trying
k
to
cap.
tell. Yes, so 2 plus 12 plus 1, right? 15, right? If you take dot product, what will you get? So if you have a pen paper, try it then. Okay, fine. This is what we will get, like 2 times. So you multiply like this, and this, and you get it. Huh?
15.
15, yes, 15. Okay, this is an easy question. So in your assignments you will have some like easy, tough, it's a mixture of it. Okay. Okay, now who will tell me what this question's answer is? Okay, forget about first two options. We'll come back to it later. Let's look at the C. Option C. Okay. So look carefully and without calculating anything, what can I tell about this option C? So it is saying A plus B dot A cross C cross A plus B. So usually try to solve them not by doing any explicit calculation, but try to look for tricks. Tricks means physical intuition, tricks developed from physical intuition. So if you look at these two vectors and this vector, you see both has this a plus b in it, right? A plus b, a plus b. So imagine you have a vector, you have b vector, right? So which direction is a plus b? This direction, right? This is a plus b. Okay. Now a plus b. Now let's say you have another vector c like this. So you have a plus c in this direction, a plus c. Now if you take a plus c cross a plus b, these two guys cross product will have in this direction, perpendicular to this plane, right? Now you have to take dot product with this a plus b, which is perpendicular to this plane. Now if you take dot product of these two perpendicular vectors, what will you get? Hmm? 0, exactly. So this is correct. Without doing any calculation you can tell it. Anyone did not understand whatever I just said? I said a lot of things. Please tell me, then I will repeat. Or if you did you understand, just tell me. Raise your hands or write in the chat that yes. Whatever the logics I gave, constantly I was saying some things like this direction, this direction, this direction. If you didn't catch it, please tell me now. Or if you, because someone raised a hand, so did you understood or did you not understood? Which one? You can write in chat. If you don't feel like unmuting yourself, you can write in chat. Shrine raised a hand. What does it mean? Shall I explain again or not? Write in chat, no? This guy raised a hand and didn't say anything. Okay. No one is saying anything. Okay, I'll just ask Aisha, are you there? Aisha Taha. Okay. Archanaba, Atul, there is another Aisha, right? Aisha Jahash. Are you there? Pavala Murthy, Manisha, Shrine. What, like, shall I explain again? Okay. Okay. I'm not getting it. What you guys are telling? Okay, let me try to explain this next question. Okay. Next question is next answer. So let's say you have A, you have B. Okay. Okay, what just happened? I don't know. Then you have A plus B like this. A plus B. Then let's say you have C. Okay, like this. Then which direction is A minus B? This is A minus B. Okay, and let's say this is A plus C, somewhere around here. This is A plus C and this is B. So this is A minus B. So what we have to do, A cross C cross A minus B. So A cross C first we have to do. Okay, then that means A cross C is in this direction. This means outward, A cross C. Then A minus B, we take cross product with A minus B again. So one perpendicular vector, one in plane vector, you take cross product, you get it back at the plane again. Somewhere, let's say this. So this P vector, this is P vector, which gets back here again. Now A plus B in the same direction, dot product might not be 0, correct? Someone wants to join. Okay. Okay. So you understood this, Anjali or everyone, why this might not be 0? Because this comes back at the same plane as A plus B.
Could you explain once more, sir?
Yes.
Could you explain once more, sir?
Okay, so I am trying to make you solve it via via geometric interpretations. So we could have done it in different way also. So let's say you have A, B, this is A plus B and this is A minus B. Now you have to do A cross C. So let's say this is C. Now A cross C. A cross C is the out of plane, right? A cross C is out of this plane. Now you have to take cross product with A minus B, this vector. So one vector which is out of plane like this, let's say like this, and A minus B. So it will come back to the plane, right? The direction of it. Let's say somewhere here or somewhere here, P vector. Right?
Yes, sir.
Now this P vector you have to take dot product with A plus B, which is in the same plane. Maybe it will do create some angle. Now P dot A plus B might not be 0.
Yes, sir, I understood.
Always, yes. Another way of calculating is to take something like, let's say define A plus B equals some P, and then A becomes P minus B, and so this becomes P dot P minus B cross C cross P. Okay, so whatever this vector is, so whatever this vector will give you something, let's say Q. So P dot Q cross P equals 0, because this goes out of the plane, right? Yes, but this might not be 0. Okay, so these two we have resolved. What about this first term? Do you remember what A dot B cross C equals A cross B cross C. There is a formula. Yes, anyone remembers the formula?
A plus B plus A dot B minus B dot C.
Yes, it's back minus cab. That's how we used to remember. Back minus cab. What does it mean? It means B A dot C
A.
minus C A dot B. Okay, B is this. So back minus cab. That is how we used to remember. Now you tell me from the same concept, and do you know from where this formula comes? Like you can write it explicitly and show it comes out to be like this. There are multiple ways of proving it. I am not going to prove it all of them. I can find it in any book. Now tell me what will this be? So C B dot A minus A B dot C, and last one C cross A cross B, which is A C dot B minus B C dot A. Okay. Now if you sum all of these three, what will you get? This guy and this guy are the same or are they different?
They are directionally opposite to each other.
Directionally opposite.
They're same in magnitude but directionally opposite.
Why do you think they are directionally opposite? Because of this minus sign?
There is a minus sign.
Okay. Not because of A dot C and C dot A, right? Because this minus.
Dot product because of the negative sign, sir.
Because of a negative sign, exactly. So if you take sum, what will happen? This
It will get cancelled.
Cancel, exactly. Similarly, this vector and this vector. What about these two?
They are also directionally opposite because of the negative. We get cancelled upon addition.
Exactly, and these two also, right?
Yes,
so all of this gets cancelled, and this is the right answer. But definitely, obviously, this would not be the right answer because this is the opposite sign. If you put opposite sign, then you would not get the same answer. Okay. Let's say find two pairs of from this. So PQR is given. You have to find two vectors from this which are perpendicular and two that are parallel or anti-parallel. Okay, try it yourself, everyone. Please try it yourself. It's very easy. You have first find the perpendicular. Okay, tell me, how do you find two perpendicular vectors? How do you find two perpendicular vectors? So
by calculating the angle.
How do you calculate the angle? Oh no, don't go in that formula. So let's take dot product. What will happen if you take dot product of two perpendicular vectors?
It will become 0.
Exactly. So find two of the vectors whose dot product is 0 among this PQR.
P and R.
Yes, P and R.
P and R are 3 minus 4 plus 1. Yes. So P and R are perpendicular. Everyone understood how she did it? P and R. You take dot product of these two. You get 3 plus 3 minus 4 plus 1. Okay. Now find and parallel or anti-parallel. Parallel means just one has to be a scalar multiple of the other. Antiparallel means one has to be the scalar multiple of other but with a negative sign. Simple.
P and Q.
Yes, you just multiply it by 2. Okay, so everyone else could do it or not? Okay. I'll just assume you guys know this stuff. Okay, someone sent a like button. Okay, good. Thank you. This is also how you can communicate actually. That's how I will know that you are here. Otherwise, I'll think just you are sleeping or something, which is completely fine. Okay, so in 4 vectors A, B, C, D all lie in the same plane, show that A cross B cross C cross D equals 0. How will you do it? So they are saying A, B, let's say C, D. So A cross B is this, C cross D is also in the same direction. Okay. So if you take cross product of 2 vectors in the same direction, what will you get? So these 2 and this 2, let's say this is P, then this is Q. A cross B is P and C cross D is Q, but you know from the direction P is parallel to Q. Now if you take cross product of 2 parallel vectors, what will you get? So this is, yes, Anjali.
0.
Why?
Sin 0 is 0.
Exactly. So this is how you show it. It's very easy. Very basic class 12 stuff. These are. Starting with C equals A plus B, so that C cross C is equals 0 leads to this. So try it first. Just calculate C cross C. if you are struggling, are you doing or I'm just waiting? Shall I also do with you? Okay. I'm guessing you guys are doing it. C cross C equals A plus B cross A plus B, which is A cross A plus A cross B plus B cross A plus B cross B. Okay. What is A cross A is 0 plus A cross B plus B cross A. B cross B is also 0. C cross C is also 0. So you get A cross B minus B cross A. Okay. Did you find it difficult or easy?
Easy.
Yes. This already we have done, A cross B cross C. So from back minus cap thing. Okay. Okay, now try this. This is a tough one. Is it? Or maybe it is very easy. So you have to calculate A cross B dot A cross B. How will you proceed? First tell me, how will you proceed? Since no one is responding, I'll ask Anjali. How will you do it?
A plus B dot A plus B.
Let's say we do it the old fashioned way. We calculate cross product like this. There are multiple ways of showing it. I am showing you the not so complicated way. Just calculate the cross product. So what do you get? Everyone here I assume knows how to calculate cross product, right? You can also try. I am just doing it to sharpen my memory. Okay. Okay, good. Now you have to take dot products of these two. Okay. So this same thing with dot product. So that means AY BZ minus AZ BY, you get a square plus AX BZ minus AZ BX square plus AX BY minus AY BX square. Okay. Now what? That is the question. Now what will I do? How do I do? Prove this to be equals. One thing is you just start with this, take this square and you reach here, or you go from this to make it look like that one. It is a very big calculation, so you want me to do it? Let me try to do it. So AY square BZ square plus AZ square BY square minus 2 AY BZ AZ BY plus x square BZ square plus AZ square BX square minus 2x bz az bx plus ax square by square plus ay square bx square minus 2ax by ay bx. Okay, now look at the square terms. Okay, so you have to represent it as ab whole square. So ab means mod a mod b, so that is ax square plus ay square plus az square like this times bx square plus by square plus bz square. So you can take common, let's say from these two you take bz square common. Okay, so you get ax square plus ay square. Are you following me? From these two, no, sorry, okay, from
Sir,
yes,
proof, I proved this
you proved this.
without,
How?
yes sir, without that, so
Okay,
without that complex calculation.
okay, I'll come to you. Let me finish this. Okay, so this is z. This is doable from this, right? Let's say bz square. Is there any bz square available? So let's say from here I take az square common, bx square plus by square, and no. Okay, it is, other than this we can just write down this and show, like from the reverse order, like from here you stop it here and you calculate the RHS and you can show it that it matches. So in RHS you get ax square bx square plus ay square by square plus az square bz square plus ax square by square plus ay square bx square plus ay square bz square plus the third term az square bx square by square plus z square bx square plus az square bz square. So these, all the terms are here, you see, all these terms, these and this are basically this, and a dot b whole square means ax bx plus ay by plus az bz. Now if you take whole square of this, you get 2ax bx ay by like this term, which are like this and this. Okay, it is showable. Now Anjali, how did you do it? Tell me.
So first of all, I open the a cross b, that is ab sin theta dot ab sin theta.
Okay,
Yes.
so let me write ab sin theta dot, oh I see, what did you do? Nice.
Yes.
1 minus cos square theta you wrote, right?
Cos square theta and cos theta can be written as a dot b divided by ab sin theta of ab.
Yeah, so this is ab whole
Yes.
square minus a dot b.
Yes sir.
Nice. This is a nice technique. Very quick technique. Good job. Okay, everyone else understood how she did it? Nice. Good job. Okay, find a vector that is perpendicular to this and this. How will you do it? So you write it as a x cap, a1 x cap plus a2, let's write abc, okay, a p y cap plus c z cap. Now you have to find abc such that a is perpendicular to both of them. So what we shall do? Let's take dot product, right? Whenever we see perpendicular, we should first think of dot product. So it is 2a plus b plus minus c. This should be 0. So this comes from a dot u. Okay. And a dot v, it should be a minus b plus c equals 0. Fine. So from these two, you see if we sum these two equations, you get 3a equals 0. So first information you get is a equals 0. Okay. Now if you put it back here, you get b equals c. So b and c are equal and a is 0. So a becomes, so let's say this is some k scalar, so k y cap plus z cap. So this is a vector which is perpendicular to both u and v. A is perpendicular to both u and v. Okay. Now if you ask me what is k, k can be anything. So k can be 1, 2, 3, 4, like any scalar number, does not matter, it will always be perpendicular to u and v. Fine. Now if you what is a if in addition to this requirement we demand that it have a unit magnitude. So if it has a unit magnitude, then this k should be equal to 1. Then it will have a if it has a unit magnitude, that means root over k square plus k square should be equal to 1. So root 2k equals 1, then k equals 1 by root 2. So then if you have required that it has unit magnitude, then a becomes 1 by root 2 y cap plus z cap. Okay. Everyone, any doubts here?
No, sir.
Okay.
No, sir.
Good. Next is, this is the last question. So let's C equals a plus b. Then we have to choose between these 4 options. So mod c is always greater than mod a. So how will we would do it? Like how we shall do it? What do you think? Let's say this is a, this is b, or anything like this. Okay, this if I take b like this, it will be easy to understand. Triangle law and all. C. So C equals a plus b. Now you tell me what is mod C? A square plus b square plus ab cos theta, right? You remember this? Now tell me what is the maximum value C can have from this expression. What is the maximum value?
The maximum value is where theta is 1.
Theta is 1.
Value of cos theta is 1.
Exactly. One value of cos theta is 1. So if cos theta is 1, then this becomes a plus b, right? And C mean is parallel of cos theta minus 1, that is a minus b. So you can see C always stays between these two. So whatever the theta is, that defines C, it can be between a plus b and a minus b. Okay. So if a and b all are greater than 0, then what can you say about the answers? Why is a and b greater than 0? Because a and b are the magnitudes. So we are calculating for a finite magnitude always. So mod C is always greater than mod A. Is it correct or not? From here, what can we say?
It is correct.
It is correct. Why? C is,
Because its value lies between a plus b and a minus b.
yes. So will it be always greater than mod A? Or will it be always greater than A? Let's say C equal to 3 and A, B and 4 and 2. Does it satisfy this? A and B are 4 and 2. Does it satisfy this?
No.
Yes. C can be small because this tells you C is smaller than A plus B, but this tells you C is greater than A minus B, right? So C, so you subtract some positive value from A to get C. Okay. Now next is, it is possible to have mod C less than mod A and mod C less than mod B. Is it correct? Yes, it is correct. It is correct. So let's say C is always equal to A plus B, which is not correct because it is not always equal to, it is a max and min value. For same goes for these two. So only option correct is this. It is possible to have mod C less than mod A and mod C less than mod B. Right? Any doubt? I think Anjali has some doubt or someone has some doubt. Okay, if you don't have doubt, this was the last question I had. So this was the first week. This will go on similar way, like I'll come and solve some previous year assignments. So the first part was previous year assignments. These were some questions I added. So I guess this first class was pretty basic. It is it's not up to your level, I guess. You are, because you are all MSc students or completed BSc or BSc students. This class goes on for, it covers really, this course covers really good syllabus you should follow. So okay, so don't just rely on the tutorials because you have to follow the main lectures. because I would not cover whatever is covered in the main lectures. I would try to solve some problems, and if a concept comes up, then only I will go. I'll discuss that. That's how it is going to happen. And please respond. Please communicate. Otherwise, I get lost what you are understanding or not. Another thing is, if you have any query or any questions or any problems that you are facing, any doubts, and you want me to discuss in the next class, please you can email it me to this one. Is it visible? How do I make it visible? You get it. So this email, this is my email ID. You can write it to me. Anyone can write it to me, or then you can send me problems also. I can try to solve it for the next in the next session. And what else? Okay, who? I guess everyone here is in the tutorial, in the discussion chat. Is there a discussion chat? Is there, or it is not there? Because I am not in there. That's why I am asking you guys. Are you all in there? Yes or no? I couldn't get it, Anjali.
I'm not aware of the discussion group, sir. I have to check.
Okay, so the thing is, I am not in that discussion group or chat, but I didn't join the course also. So okay, fine. So that's it's nothing. I just asking because sometimes there's some information are passed there, and if one class, like if I miss one class, I'll try to communicate somehow. It will be great if you drop an email to this one, just saying hi, or write in subject that Newtonian mechanics tutorial. If you want, like you can drop an email to here, then I can also communicate it directly to you. And if I, like, let's say if some week I might not be able to take a class, then I will reschedule it. That it will be great if I can communicate with you in that way, because the discussion group is there or not, I'm not sure, and I'm not there. That's the main point. So if you can drop an email to everyone, whoever wants to continue joining this tutorial session, please drop me an email in this one. Just in the title write this. Okay, just this part, just in the subject write this. I will know what to do with it if you feel like it. No pressure. Another thing is, this whatever we did, this PDF and this video recording will be shared with you. The link, it will be on YouTube, and this will be shared via Google Drive, and you can have access to it later also. Okay, any questions?
No, sir. But just one thing, I have just checked the discussion group is there. Means I have just checked the Q&A section, and I have also just joined the group. Earlier, I was not aware about that. But yes, the discussion group is there.
Okay, I am not in there, so I need someone to communicate there. Okay. So I'll tell you guys in the main class, and so drop me an email, all of you. If I say something, like something about let's say 1 week, that is a timing change or date change, I need someone to communicate it there. Okay. I need your help with that.
Okay, sir, sure.
Okay, great, and keep joining, and I hope you like it. Fine.
Yes, yeah.
Thank you then. Okay, then
Yeah, thank you,
I'll
sir.
end today. See you next week.
Thank you for the session, sir.
Yeah, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Fine. Thank you. Anjali, you want to say something?